This is lesson 13.2, theoretical probability of compound events. Like we had mentioned before, probability can get a little bit more complicated, a little bit more difficult. And so we're going to look at those slightly more difficult situations. Still not very hard, but just a little bit more than we were looking at before. So we're going to think about compound events. That's two or more events. When we're looking at two or more things happening. And if you think about a compound sentence, like in English class, that's two or more sentences. So it's the same kind of thing. We're just kind of smushing multiple problems together. And then there are multiple types of compound events. Independent and dependent are the ones that are the most common, and the independent events is what we're going to focus on this year. You'll learn about dependent events at another time. So independent events, the first event doesn't affect any other events. And it kind of goes like this. If I spin a spinner and then roll a dice, well, there's nothing about the spinner that says, hey, if you spin red on the spinner, then you can't roll the dice. There's no rule that says that. They don't affect each other. To maybe make myself a little clearer, let me give you an example of dependent events where things would be affecting each other. Let's say that I had a cookie jar full of all different types of cookies. Chocolate chips, snickerdoodle, sugar cookies, peanut butter cookies, Oreo cookies, all the types of cookies. If I reach my hand down into that cookie jar and pull out a chocolate chip cookie, and then I eat that cookie, well, I can't ever pull that cookie again back from the jar. It's gone. It's in my belly. And so there are less cookies in the jar than there were before. And there's also less chocolate chip cookies because that one's in my belly. Delicious. So independent, the different situations don't affect each other. Dependent, they do affect each other. Let's just look at some of these examples. So you roll a 6-sided die one time. After that, you randomly pull a scrap from a bag of scraps. The bag has 4 green scraps, 4 blue scraps, and 3 yellow scraps. They want to know the probability of rolling a number less than 5 and then drawing a green scrap. So that's two things going on. We've got two different little probabilities we want to find. The first is getting a number less than 5, and the other is picking a green scrap. Well, I'm going to treat these like two separate problems at first. So less than 5, that's 1, 2, 3, 4. Those are the numbers on the dice that are less than 5. So that's 4 out of 6 will work. And green, well, there's 4 green scraps out of 4, 8, 9, 10, 11 scraps total. So now that I found each separate probability to find what would happen if I got less than 5 and a green scrap, I'm just going to multiply them together. So 4 6 times 4 11ths, and that's 8 over 33. Okay, so a bag contains 4 orange rocks, 2 green rocks, 2 white rocks, and 3 yellow rocks. If you randomly pull a rock from the bag and put it back, I'm going to underline put it back, and then pull out another one, what's the probability of getting an orange and then an orange? So if you think about it, if I put the rock back, then there's still the same amount of rocks, and there are still the same amount of orange rocks in the bag. So nothing has changed if I put it back. If I were to take that rock and throw it or just kind of leave it out of the bag, then that would be a different situation. But since I put them back, it's just the same thing as it was to start. So orange, well, there's 4 orange rocks. 4, 5, 6, 7, 8, 9, 10, 11 out of 11 rocks. And, oh, this one's nice and easy. It's the same one, 4 out of 11. So to find the chance of me doing that twice, pulling an orange rock, putting it back, pulling another orange rock, I just multiply the probabilities together. Okay, so we spin a spinner that's equally divided into 9 parts. And then you spin it again. 3 are red, 1 is pink, 2 are green, and 3 are yellow. What's the probability of the spinner stopping on a red section first and then a pink section on the second spin? So I'm going to look at each probability separately. Probability of red, and the probability of pink. So red is 3 out of 9, and pink is 1 out of 9. So the chance that both things happen would be 1 out of 27 when I multiply those probabilities together. Okay, so you randomly draw twice from this deck of cards, and here they are listed. What's the probability of drawing a C and then drawing a C? And we're going to replace that card to make sure that they're all back in the deck again. So the probability of a C and the probability of a C. Well, there's 1, 2, 3 C's, and 1, 2, 3, 4, 5, 6, 7 cards. So both of these probabilities would be the same because we're picking the same thing. And then I'm just going to multiply to find the chance of that happening twice. Picking the C, putting it back, picking up another C. Last problem here. Jacob stood in line to pick up a souvenir postcard at the museum. All the postcards were either blue, white, or green, with a picture of a fish, insect, or bird. There was an equal number of each type of postcard. What's the probability that Jacob will randomly be handed a green postcard with a fish on it? So I want the probability of green and the probability of a fishy. All right, so the colors are blue, white, or green. So getting green, that's 1 out of 3 choices. And then to get a fish, well, there were fish, insects, or birds. That's another 1 out of 3. So the chance of that happening is 1/3 times 1/3, or 1/9.